afternoon, everyone. We're almost to noon, which is our every Wednesday lunch and learn. And we'll let a few folks continue to roll in here until we hit that 12 o'clock hour. Looks like we're there. So today we've got Rob Mitchell. Rob is a PLS. He works out of our Montlake Terrace store up in Seattle, Washington. Rob's going to be talking about Hexagon networks. And Rob, that's all I think I need to give you for introduction. You're well enough known. We'll just roll right ahead with you. Take it away.
Thank you. Thank you, Douglas. Thank you, everyone, for joining. Welcome to the Lunch and Learn. We do these every Wednesday on different products, services, new technology. We've done software, scanning, drones, all sorts of things. And today we're going to talk about a service that's provided by Hexagon Leica called Hexagon SmartNet Global. It's a correction services for your RTK networks. It's a correction service that not a whole lot of folks know about, so I'm excited to share it with you today. So let's get to it. I'm going to share my screen here. Share screen 2. Okay. Everything looked good there. So we are Kuker-Ranken. I'll just briefly, we've got offices and knowledge base in Seattle. We have offices in Tacoma, Boise, Salt Lake City, Nevada. So we have a lot of the Western states, and that means a lot of knowledge, a knowledge base for our sales reps in drones and scanning and the technology available. And you can reach out to us at any time. We've been around since 1928, and we've got brick and mortar everywhere. So obviously, Kuker-Ranken is a very unique name, and Google searching, and you can reach out for information if you request any kind of services or hardware. So I'm going to talk about just a little bit of history of what RTK is for those of you that it'll be brief, just what it is and how it works. Essentially, if you're traditionally what you use with RTK networks is there is a network of permanently mounted base stations, GPS antennas that receive corrections. Right here is the North American network that Leica has called SmartNet. And these little green dots are permanently mounted base stations that receive that GPS information. You can have third party. In Washington, we have another system or network that collects information. It's called the WSRN. It's just a similar methodology, and this here is in Washington, and these are their base stations that are permanently mounted, evenly spaced throughout the state. And back to the SmartNet network, you can see all those base stations. This is the coverage area of where you can receive corrections if you have internet and you have a subscription to the SmartNet to get centimeter level accuracy on your GPS receiver or rover. You can see there's a lot of white spots, which is where there is the reach of those base stations or the vectors or the ability to get RTK quality corrections in some of the unpopulated areas and some areas that are just remote, haven't been filled in. And so traditionally, what do you do to utilize your GPS tool, which is a high-end tool for surveying or GIS or construction? And how do you utilize that efficiently? And you have that tool and you may be working obviously in Northeast Washington or down in Idaho. And how do you take advantage of that? Well, you could get another receiver and use it as a temporary base station and do corrections that way. But Leica has come up with a service and a solution since 2013 approximately, where you can have another couple options, and that's what we'll talk about today. So how does it work? Briefly, these base stations, those points that you see that are permanently mounted in various areas, just get GPS information. They collect information, get positional raw data, and they send that information from what they collect to a server location. So a SmartNet server or some sort of control center, and their positional data is calculated at that server. And then your surveyor, your GIS person, your construction police officer who's doing the crime scene hops out of the truck, pulls out the unit, and gets a position on his rover. Now, he needs internet. Traditionally, you need internet access, some sort of internet, either a hotspot of a phone, a Wi-Fi device, a SIM card in the antenna or the controller to be on the internet, because he has a subscription to that server, an IP address. And he or she also needs to collect information, GPS information on the rover. So that's why he has that high-end antenna. So he gets a rough position of where he's at on the planet using the GPS constellations. He has the IP address and he has internet connection and he has a subscription. So he sends his rough position to the server. The server calculates the corrected position and sends it back to him. So then he gets centimeter level accuracy and away he goes. That works great in areas of internet and works great in area of those base station coverage maps. But what happens when you go into, like I said, Northeast Washington, where you don't have either internet or internet is spotty, or there are just some places in the county that internet does not work, or you're outside of your network. And we're going to switch over to this so we can talk about the main topic of today. Hexagon SmartNet Global. Okay, so this is, I'm going to just talk over this video as it goes, but here are the satellites. And what SmartNet Global adds to this solution is, as soon as it scrolls across here, network RTK. That's what we're talking about right now. The traditional way is network RTK. There are base stations set up. There is corrections received. And what SmartNet, Hexagon SmartNet Global includes is some additional services that can get you those corrections needed. RTK bridging and PPP, or I had to write this down, precise point positioning. Okay, so what are those two things in addition to the network RTK? All right, so here's a control center. Here's your rover. Here is that regional reference station network. So this would be that SmartNet. We're in Washington. We have those permanently mounted base stations. We could certainly have a temporary base station as acts as our base station. And you're within also, you're within your network, and you're also within, if you notice down here, mobile internet coverage. So you have internet, you have GPS constellations, you have a rough position, you have a server. This is what we talked about just briefly before. You have your regional reference station network. It's sending those corrections to you, and you're getting a centimeter accuracy survey. So what happens when you lose either the internet? So now you're outside of the internet, so you lost that internet connection, or you're outside of your network. Well, that's where SmartNet Global comes into play. This satellite is a geostationary satellite, and there are 5 of them. I'll show you an image of that. There are 5 of them that are just positioned around the globe and turn with the globe around the equator. And if you have visual sight line to that satellite, to that geostationary satellite that I believe is the owner is Novotel, it will, the way I think of it is it provides a base station information in the sky. So it's, there you go, geostationary satellite. It is sending information for up to 10 minutes of centimeter level survey grade quality RTK position to you for up to 10 minutes. And that is, if you've lost, you're in the network, you lose internet, you have a fixed position, you have this service, you can bridge that RTK quality outside of internet for up to 10 minutes. Or if you're out in, say, I have an example in New Mexico where a surveyor was doing project similar to this. We rented this system to him, and he was in internet, he was in the network, SmartNet, and his project extended out to where this person is located outside of the network and outside of mobile. And it switched to the geostationary base station in the sky for up to 10 minutes. He was able to accomplish the mapping he needed to accomplish for the project. In some very rural New Mexico areas. So that is 10 minutes, that is certainly helpful. It's helpful when you're moving down a project or your project is a river or a highway where there are intermittent access to either the network or the internet. So what happens if up after 10 minutes you lose, that fix? Well, that is where the PPP comes in, and that requires a little bit of convergence information, but that allows that base station in the sky, once you have maybe 10 minutes of information, let's see if the line comes back up, you have the ability to get centimeter level accuracy. It takes a little bit more, maybe 8 to 10 minutes to get converged once you want to start the PPP. So an example of where this is extremely useful is if your project goes more than 10 minutes where that bridging doesn't complete the project, PPP can kick in and you can work away using just geostationary satellite information, that base station in the sky. Or let's say you've got your project is in the middle of Montana where you saw there wasn't much as far as SmartNet coverage. You start out with PPP, the convergence, to get started would take, 10 minutes. Now this technology, this link or this RTK bridging in the PPP has been around since about 2013. But what really excited me just recently and I'd like to talk about this topic is up in Washington, that geostationary satellite that we see that's moving around the planet is fairly low on the horizon. So a building or tree coverage or any kind of interference with the line of sight of that satellite would affect the ability to work away. Not a problem in the Palouse or the desert where there are no trees or limited buildings where you can work away because you have visual to that satellite. But up in Washington, it was, hit and miss. And in May of 22, so, just in the last 7 months, they've improved this service where you don't need necessarily, you have options. You don't necessarily need line of sight from this geostationary satellite. That works. But you can also, if you get back into some sort of internet coverage, you can utilize that control center using PPP as well. So if you are in trees or buildings or there's mountains or something, you can either use the visually see that base station in the sky or through the internet if you have the ability to do that. So that alone to me is a big step up in the ability to utilize this this technology, this base station in the sky. Here's just a screenshot of those 5 geostationary. So they sit over in this position around the globe, and like up in Washington, down in New Mexico, it's a little bit higher in your, visually seeing, and there's a lot less trees down in the southwest area there. So up here, it wasn't as efficient to utilize this, but now with the fact that if you have internet access with the MiFi and you're using PPP, so you're outside of some sort of network, it gives you that ability, an additional tool to use, an additional service to use where you don't have to set up a base station and use a rover. Now, now that I mentioned the base station, it does also work with that. So it doesn't necessarily have to be you have a SmartNet subscription as well as SmartNet Global subscription, which is all inclusive. But let's say you just use normally a base and a rover situation, the PPP and the bridging also works. If you get outside of your base station radio, let's say you're a couple miles out and you can't achieve that, you can't pick up that radio signal from your base station. This also works the same scenario where it will bridge you even though you've lost the radio contact to the base, or you can utilize PPP and switch to PPP and then disregard the base station. So a lot of kind of efficiencies you can use. Projects that you may think of are long linear projects, transmission lines and gas pipelines and stuff like that go over several states or go into extremely rural areas where internet is spotty. There's all kinds of projects. If you're working exclusively in a county that doesn't have a lot of internet coverage or it's spotty, this is a subscription that's kind of made for you, that you can, it'll bounce automatically between your RTK network, your bridge of that RTK network, or the PPP solution. So it's a really cool, unique service that has improved vastly in the last 7 months since they introduced the ability to not only see the base station in the sky and utilize that, or utilize the internet if you want to use that bridge capabilities. And with that, let's see if I've got this. There's your regional settings. And then on the new data sheets, or if you look online on the GS18, all the new firmware versions and software versions have the ability to run with this RTK bridge and SmartNet Global. SmartNet is part of that network, and on the data sheets, you will be able to see. I think I have a data sheet that talks about the new data sheet on the 18. Talks about right here, Hexagon, SmartNet Global. These are the services provided on that internet on the GS18 and the new Captivate antennas. And I made it within my 20 minutes. And I hope everyone had the sandwich. And I don't have access to the chat room. If there are any questions, certainly reach out to me. My email is there at the bottom, rmitchell@krink.net. And
so, Rob, one of the questions we have coming in from Facebook is, what's the difference between PPP and PPK?
PPK, post-process kinematic. So that is where you are collecting data. You have no connection to anything, and you are collecting on the rover side. You're collecting data on a certain amount of epochs. So you're basically logging and storing raw data at your rover, and somewhere you can access after post project, or at the end of the day, you can access a base station that is also at the same similar time in the similar area receiving GPS information, and you download that. You download that information and you post-process in some sort of, either Infinity or other processing software, and you download both those raw data files, bring them in, and you process the kinematic vectors so that you are getting your centimeter accuracy level after the project's completed. But you don't know until after you download the base station at the end of the day. So PPP is using that base station in the sky, and you are seeing your quality live or real-time kinematic, and PPK is post-process kinematic. So you're moving along, you're storing points, you just you have to process it after the fact. Hope that answers that.
Okay, that's only, can I use other GPS besides Leica? There's a question we have coming in. Can I only?
No, you can, all those networks, there are different various manufacturers you can use. The service, though, is Leica specific. Yeah, so the PPK, the RTK bridging is like a specific and also new like a specific. So some of the older GS14 generation, GS15s generation don't have this ability to get on the bridging and the PPP. Certainly you can still use them with SmartNet, or the ORGN in Oregon is another local, actually it's a SmartNet product, like a product. Utah has SmartNet, Idaho, SmartNet. So yes, for the SmartNet part, for the PPP and the RTK bridging, like it.
Okay. What is the cost of the service is one of the questions we've had come up here.
Yeah, I don't call. So the SmartNet that we sell a lot of, it's $2,500 per a year per state, and then you can get regional, you can get multiple states, you can get a national one that prices go up that per year. And some of it is we have competitive pricing, WSRN, which is the Washington State Reference Network. We are competitive with them, and so our prices are about $1,850 a year for the network, which is right at the same price as WSRN, and we have half our customers in both. The PPP and the RTK bridging, I have to, I'm kidding, but I'm not. You have to reach out. It's there's different levels, and I'd be remiss to give a quote out right now because I am not 100% sure. So
understood.
I can find it. Yeah.
A couple other questions that are coming. They actually follow right along with cost. Is there a difference in quality or accuracy between PPP and PPK?
PPP and PPK. I don't know what PPK is. All dependent on your distance from where your base station is located. So if you look at SmartNet or GPS on this data sheet, which I stopped sharing, but on the data sheet, it's always like if you're using SmartNet and your base station is nearest, there's an inherent error of, let's say I believe it's about 0.8 centimeters. So 8 millimeters plus or minus 1 parts per million. So every kilometer you get from a base station, you add a millimeter of just inherent error. And then there's always conditions, environmental conditions, whether you're in buildings or, tree coverage or whatever. Now you move to the RTK bridging. They've improved it about 5 millimeters. So it's about 2.5 millimeters accuracy, precision, plus or minus 1 part per million. So your error increases if you utilize the RTK bridging or the PPP. So those are very similar, 2.5 millimeters plus or minus error. With PPK, I am not sure that because there's a little bit more dependent on the base station information you gather. So we used to do PPK from Coast Guard beacons, where we would download the Coast Guard beacons up the Columbia River. If you had a base station that only is set up to receive every 5 seconds of GPS and GLONASS, where on your rover you are collecting information on 4 constellations at every second, you download both data sets, you're going to get a little bit different accuracy level. So I can't specifically answer the difference. I do know that in real time with the PPP, you can see what your accuracy is in the 3D quality live right there on the screen. I don't know if that answers that question. But
and what looks like our probably our last question here, because nothing's come in the last 60 seconds or so. Can you use these systems for GIS?
Absolutely. It's made for all those systems. If you had a tablet with GPS RTK capabilities, which even drones with RTK capabilities, I'm not sure about it automatically switches, but with GIS and tablets and RTK antennas, L1, L2 quality, you log in, you activate it, one-time activation, and it will switch. And yes, absolutely, you can use it with GIS. It's a very great tool for GIS.
Great. Well, that looks like all the questions we've had come in. We haven't had any additional ones come in, so we'll remind folks that we have our Lunch and Learns every Wednesday at noon. I'm going to ask if we can get our Lunch and Learn schedule posted there. I think our moderator's still in the background. Yep, there we go. So we've got quite a few Lunch and Learns that are still coming up yet. You'll also you can sign up for our newsletter if you'd like. You can see that in the chat link that's down below. Next up, next week, we have Brady Reich doing part 2 of the animal presentation. On February 15th, we've got Jeremy Kippen, who's going to be doing an introduction into the Leica Captivate line. On February 22nd, we've got Matt Kowalski coming back with Leica My World. And then additionally, want to remind everyone that doesn't have one yet, the Kuker-Ranken 2023 calendars are available for us to ship to you. If you just want to reach out to Noel at crank.net, you can see Rob's calendar hanging in there over his shoulder. And Noel, her email address is right there in the chat box, and we would be happy to send these calendars out to you. They're $20 retail value. And we're thrilled to get these 15-month calendars onto your walls. And we also have the new Kuker-Ranken catalog that's ready to be shipped to you. So folks, that brings us to thank you, Rob. This brings us to the end of today's Lunch and Learn. We're grateful to Rob Mitchell and bringing his many, many years of experience in the field of survey to you. Please stay tuned for future Lunch and Learns that we have coming forward. And we'll see you all next Wednesday. Be safe out there, everyone.